Hey everybody, I just wanted to make a quick video and go over something that I went over with some of the students during the extra coding session this week. And I just an attempt to give you an intuitive idea of what recursion is doing, so that maybe it'll help it click a little bit more, right? And you've been told over and over this week that recursion is just breaking a problem down into smaller and smaller pieces. So maybe I thought a visual representation of that would be a great way to sort of get an idea of what it actually means, right? So let's say we start off with the question. We want the area of this square, okay? And we don't really know what the area of the square is. And let's say we don't know how to calculate the area of the square. It's too big. Like we have no idea what this means, right? But we know that, well, if this is a square, then surely it's made up of four smaller squares, right? Oh, that's terrible. Four. Jeez, why isn't it? Okay. Four smaller squares, right? Okay, so we know that, okay, that's cool. But we still don't know what the area of the square is. We still have no idea. And then we repeat the same logic. Well, if that square was made up of four smaller squares, then each one of these squares should in turn be made up of four other squares, right? And indeed, that is the case. And suppose we finally get to the point where, like, oh wait, we know what the area of this small square is. Where we just know, like we've been told that this actually is 1. That's right. We know the area of this square is 1. Area of 1 square equals 1. I'm just calling it 1, right? And the idea is now that we've gone down to this level, this this returns this value of 1. This is the last call. This returns a value of 1, and this basically comes back up here and says, hey, actually I know the area of one of these. You are made up of 4 of me, and one of me has area 1. So this function goes, oh, okay, I'm going to take what you returned, and I'm going to multiply that by 4, because I'm made up of 4 of those, right? And then this sends it back up here. It says, hey, you're made up of 4 of me, and one of me has area of 4. And this function finally goes, oh, right, and you're made up of 4 of me. I'm made up of 4 of you, and and one of you has area of 4, so I'm going to multiply you by 4, and then I'm going to have the answer that my area is 16. So that is the idea, right? And so you break it down, and then you come back up. That is the basic idea behind the principle behind regression. Sorry, not regression, recursion. It's going down, down, down to a level where you finally get the answer. So this is the base case, right? This is what you've been told is the base case. And every recursion function has one of these, and it comes back up, and you finally get the answer, right? So I hope that made intuitive sense. And generally speaking, when we're trying to write the piece of code, I would also say, like, the the general strategy that I use is sort of break the problem down into little pieces like this, right? It doesn't have to be recursive, but like if you have this giant mess of a problem, right? And it's like I have no idea how to solve this. Like if I asked you, hey, I want you to find the area of this blob, I doubt any of you guys would know how to do that, right? I don't know how to do that, but I know that this blob is actually probably made up of tiny little squares, right? Teeny tiny little squares. And figuring out an area of a square is pretty straightforward. So if I put all of these things together, eventually, so let's just call this big problem, right? This huge dragon, it's impossible to solve, but we know that it's made up of these tiny little dragons, and we can kill these guys. That's no problem, right? And eventually we chain them together, and we'll finally have solved this problem of figuring out what this is. right? And that's sort of the general idea of trying to build a program. Is like if you're stuck, if you don't know where to go, try to break the problem down into its tiniest components. The tiniest components that you can actually implement, right? So that might be something like, hey, okay, I know this problem needs an input, so hey, I know how to get input, so like that I can do, right? I know how to do this function needs to add two numbers together. Hey, I know how to do that. So find a foothold, find a place that you can actually start doing something, and then build upon that to come to your solution. And that's generally been my approach, and it's been rather helpful. So hope that was useful. And if you have any questions, please post them on the discussion board. And if you have troubles, attend one of the sessions, either mine or Lotta's. So yeah, good luck.